must finish this because we don't have a lot of time already. You know, now it's already April and it's the 19th of April. We're approaching May. All right, once you approach May, right, how many months you have? Can do countdown. One hand can finish. How many more months? Four, right? May, June, July, August, and September is the start, right? The end of September is the start already, right? So 4 plus, 4 months plus, right? So you see, if I take 2 lessons to do one paper, how many more lessons do you have? 4 months means you have how many more lessons? Every month got 4, right? 16. How many papers can I do? I can only do 8, no? 8, no, not enough, bro. How many papers you all need to practice? You don't know? 1? No. You say 1. You do 1 paper enough. Not enough. I say minimum 20. Right? You ask your brother, ask your sister, we did like 20 papers. 10 to 20 papers. Okay? Schools. Why? Because once we do so many, right? Every time you look at this question, you know. Okay, immediately you look at this. Okay, what do you think the question is going to be about? Evaporation. Evaporation. Okay, how come got bubbles inside? Boiling. Okay, so there's boiling, evaporation, heat, you know. So we want you to be, you know, to do so many questions until you know roughly, okay, what kind of question it is. In fact, when I look at this, right, I don't think about boiling all this. I think about condensation. Why? Look at that, substance X, bubble, then after that, what substance Y? Steam, correct? Steam, okay? So that's the first thing that comes to my mind. And when I have that first thing come to my mind, I know roughly what kind of question they're gonna ask, okay? So we're gonna go through this together, okay? We're not gonna wait to do this, but what we're gonna do is we will go by sequence, okay? Let me see. Okay, one by one, right? Let's just finish this. Then after that, we will do the new set of MCQ. Okay, next. Let's start with Megan. Okay, identify the state of substance X and Y. The state, you know what's the meaning of state? That means solid, liquid, or gas. Okay, what is the state of substance X? X. It's pointing to the gas. Right, so this is gaseous state. Okay, gaseous state. Okay, how about substance Y? Let's ask Tristan. Y is the least. This one is difficult. Okay, tricky. Right. Very good. How do you know it's liquid? Eh? How do you know it's liquid? This one, this thing, no? This thing, no? Ah, very good. Okay, do you know? Does everybody know this liquid? Okay. How? Yeah, once you can see. So, how about cloud? Cloud, is it solid, liquid, or gas? Ask one more time. Cloud, is it solid, liquid, or gas? Let's ask everyone. Liquid. Or is it he thinking? Solid, liquid, or gas? Cloud. Sorry? I can't. You're talking, because your thing not moving, but I hear like liquid. Kenny, cloud, is it solid, liquid, or gas? Liquid. Jabal? Liquid. Ashton say liquid. What? Liquid. For instance, Jabal? Why? Why is it liquid? Because you can see. Can see means it's liquid. Cloud is formed by water droplet. Okay. Because it's formed through condensation. Okay, condensation is gas to liquid. Okay, very good, right? I'm glad I don't have to explain that. Sometimes I have to explain the color is a liquid. Okay, so how substance Y is formed? See, condensation. Kenny, condensation is a 2 marks question. So can you give us the full explanation of condensation? Right, I already given you the answer, right? It's condensation, but you cannot just write one word condensation, correct or not? You write one word condensation, what will happen? No. You get 1 mark, right? But here 2 marks, right? They want 2 marks, okay? Okay. Now the burden is upon you. Can you share how to answer condensation so that we can get 2 marks? Kenny, are you here? Kenny? Are you stressed? Wait. Kenny? Kenny? Can you share with us your answer? Condensation. Ah, you don't know? Oh, yeah. Who want to try? Me too. Well, okay, both try. Okay, action first. I want the full thing. Full thing. Don't just give me one word condensation. Okay. What's the full thing?
Substance that moves heat.
Substance X moves heat. Wait. You haven't finished. Substance X gain heat. What substance X?
Gas.
The gas.
Okay.
Okay. Let me type out what you say. Right. Water gain heat. Okay. So far so good. Okay. You can copy if you want. So water gain heat and evaporate. Right. Into water vapor. Then after that. Okay. Wait. The water vapor comes into contact first, right? With the cooler surface. Is it cooler surface? Cooler surrounding? Yeah, it's not surface, no surface. Comma, lose heat. Lose heat. Lose heat. Yeah. Yeah, that's what we need. Okay. So this is like the full answer for condensation. Now you don't need to write the word condensation here because the word condensation is here. Alright, so they say, oh, this person knows condensation. Oh, the water comes into contact. Okay, with the cooler surrounding loose and condense into water droplets. Okay, so this is the standard condensation description that I'm gonna ask every single one of you at least 2,000 times each. Okay, because it sure come out. Right? I always make the statement, so-called the bet with P6 students. Every single year, I think I told you, right? Every year, condensation sure comes up. Okay? You can ask your brother. Your brother bet one burger with me. I said, if you don't come out, I'll give you one Big Mac. Right? So really came out, last question, condensation. Every year, okay? Every single year, PSLE, there will be a condensation question.
So now you should make the bet with you. The thing will come out this year at the end of the question. Then if you get it, then you give us a
Give you what? Big Mac? What's a Big Mac?
Big Mac.
Oh, Big Mac. Sorry, this thing causes the voice to be a bit muffled. Big Mac. All right, yeah, I mean, come and claim a Happy Meal from me, all right? If PSLE don't have it, then say, Mr. Nick don't have, right? But I can't confirm until next year. You know, next year March when the paper comes out. Okay. No, you can't bring the paper. You gotta return the paper, man. Okay. Yeah, but they will. Okay, it will either be like MCQ or yeah, exactly. So it will either be MCQ or be open-ended, right? Sure, have this kind of thing. Okay, condensation. It has been there every single year. Next time I'm gonna say in YouTube. Okay, like everyone, hello, everyone watching this YouTube. If the condensation never come, I'm gonna give you one lollipop each. Next. Yeah, imagine really never come out. Then 2,000 people come. You need to give me a lollipop. I'll die. Okay, next. No, I won't hide. I'll be there, right? But I won't make this kind of statement, okay? To the whole YouTube, but here only 8 of you, so it's fine. Okay, so here C. So CT observed that substance Y could no longer be seen beyond region A. So this region A, right? So substance Y, that means this mist disappear after some time, disappear. Okay, what happened? Explain her observation. That means why. What happened to Y? Who wants to try? Who knows? What happened to the mist? After boiling, then the mist will be here for a while and then it's gone. What happened? No. Anyone? Half correct, half correct. How many marks? 1 mark. Right? How did it evaporate? Very good. That's correct, right? So the substance Y gain heat and evaporated. Okay, so this is actually under the chapter of water cycles. Okay, substance Y gain heat evaporate, which I think we went through before, like some time back already. Okay, P5 end of P5 you would have gone through this. Substance Y gain heat evaporated. Okay, Lisa, you copy already? Right? Okay, next. Finish? Finish? Okay, next one. Okay, so we got another. Whoa. This one, did they like draw for us? Yeah, I think they drew the thing for us. No, so no need draw. So we skip one question. Okay, so the teams were then given a circuit below. All the switches were opened at the start, so everything. They were told to identify 2 different pairs of switches to close. Close 2 different pairs, 1 pair at a time. In order for all the 5 to light up, which 2 pairs should the teams identify? Switch 1 and switch 1, right? So you close 2 switch, all 5 light up. Which 2 will we close? Let's ask Japan.
1, 2, 3, and 4.
No, let's choose 2. No, which 2 pairs? So switch 1 and switch 1. First pair, what's the first pair? 1, 2. 1 and 2, is it? Let's check. Okay, I don't know whether correct or not. Let's check. So if you close 1, you close 1, and after you close 2. I want 5 to light up, no? So here, this one light up, this one light up. Wait. Here? Here can light up. Here cannot. It's open circuit, so you cannot use 1 and 2. Okay, let's see 1 and 3. Okay, 1 and 3. So you close here, right? So okay, current come here, light up. This one light up, this one light up. Then come here. Oh, very good. So the first pair is 1 and 3. What about the next pair? Princeton, can you give me a second pair that will cause everything to light up? Or anyone else? Oh yes, 1 and 4. 1 and 4. Okay, let's see. So from here, so this battery never use, right? So electric current light up, light up, light up. So you go this way, light up, go here, this one light up, come back. Okay, very good. So 1 and 4. That's correct. Alright, that's very easy. See 2 marks. So easy to score. Next. Raju carried an experiment to see how high a basketball can bounce when it was dropped. Okay, this is another typical one as well. Okay, so when the original height is here, and the rebound height will be here. Can you tell me why? What happened? Yes, Sherman. Yeah, so some of it is converted to other energy. Okay, it's called the conservation of energy. So give a reason for so you see, once we look at this, right? Because we've done enough question, we know roughly what it is about, right? You won't go out of point. So observe the bounce side is always lower. Give a reason. Okay, Japa already gave the reason. It's because some of the kinetic energy has been converted to sound and heat energy when it bounces off the floor. Okay, so we can just stop here, right? We say some of it converted, hence there's less kinetic energy for the ball to rebound to the original height. Okay, so we always have to answer the question, right? This is the ending part. Let me highlight the ending part. See, ending part, rebounds to height. It must be lower. you gotta answer why is it. You can answer why it will be lower than the drop height. Okay, don't just leave it here and say that, oh, because the energy has been converted to sound and heat, then you full stop. So that doesn't explain why it's lower, right? You gotta explain why it's lower, right? Everyone okay with this? No, okay, wait for you. Yeah, go ahead. Next time we can put the DVD here. Put the needle.
How are you gonna move the ball? So easy.
Move like this. But I don't know, isn't it really funny? Yeah. Then you write here. Huh? Put there, put TV there. Then everyone must turn. Then everyone will be going out like that, no? Or your head is to the one side. I think here is among the one, slide anything. Never mind, think about it next time. Okay, but here is just a bit too diagonal. Okay, moving on. Let's go. So using energy conversion, explain how the loudness of the first bounce is affected by the height from which the ball was dropped. Right, so this is a data analysis, okay? So you see, the higher it is, yeah, the louder, okay? So, but here they ask you to explain, so you cannot just say, oh, the higher it is, the louder. You maybe get only on 1 mark. You have to explain why. Why is it the higher, the louder? So your start will be when the ball is at a higher height. Okay, I'll start it for you, right? So when the ball is at higher height, more what kind of energy does it have? Higher. Gravitational. Okay, it possesses or it has more. Okay, so when it drops, it will have more kinetic energy. Okay, so drop, it has more kinetic energy. And then, well, a bit hard to see, more converted sound energy. Okay, so we have the start. The start says when the ball is higher. Okay, when the ball is at a higher height. The end, you gotta end it with, therefore the sound is louder. You got it? Okay, higher, louder. Higher, more gravitational potential energy, convert to more kinetic energy, convert to this louder sound. Right? Next. Okay, computer, don't worry. You can look at the next one. We can done with this. It's like a writing exercise for you. Finish? Finish? Yes? Okay, last one. Okay, the last one. Okay, Ming was pulling a box filled with books along the floor I showed. Name the force that caused, oh, everybody knows, yes? Yes? You raise your hand? Yeah, friction. This is force. Friction. So besides causing difficulty, what's another problem the force mentioned will cause? So friction will cause difficulty in pulling. Okay, what else will it do to the box? Damage. Okay, wear and tear. So wear. And next one, how the force can be useful? How can the force be useful? How is it useful for him? Can you imagine that if there's no friction here, he will slide. Yeah, correct. Can you imagine there's no friction between his hand and the string? The hand will slide. Okay. Right. Got it. So is friction important? Yes, right. Friction is important for him. If not, he will not. If there's no friction, no force, he will not be able to hold the thing. Okay. Or he won't be able to pull the box, right? So that's how is it useful because okay, let me type it out, right? So friction enables him to stand properly without slipping, moving the box. Okay, he will not slip and fall. He will not slip and fall. So you can stand properly without slipping or pulling the box. Slipping. Okay, next one. It's our snail, okay? How does slimy substance help ants to move on the ground? So how many legs does the snail have? Huh? Are you sure? One. How many legs does snail have? One. Yeah, how many? You don't know? Kenny, how many legs does the snail have? You're closer to the snail. How many legs does it have? How many legs does it have? I thought, how many legs does the snail have? Zero. Oh. How many legs does the snail? They do not have legs, okay? But they have one flat foot. So they don't have legs, okay? But they have one flat foot. That means the whole body is a foot. Do you understand the difference? That means there's no leg. Leg is like only one leg sticking out of the hand. But the whole underbelly is a foot. Okay, so the whole snail is like a foot. This one leg. I mean, that's not leg. This is the foot. Okay, the whole thing is the foot. Alright, it's like you have your leg and then your eyes growing out of your legs. That's all. Your foot, right? And then the eyes coming out of the foot. Okay, that's how the snail is. Right. So how does the slimy substance help ants to move? Yeah, Shiraba again. Yeah. Yeah, so it reduces friction. Okay, so what? Reduce friction. Hence ants move with less force. Okay? So you see, even if we know and you identify that there's less friction, right? You gotta explain how having less friction help it to move. Okay, it helps because now it can travel with less force. Okay? Travel with less force. Right, so that's the end of this one. So what's going to happen is we will first choose a name and then we'll choose a number, okay? Or you want to choose number first, then choose a name. Choose a number first, right? So now, what? Okay, so if you okay, let's say if we choose 3, right? You must answer all correct. Then I will remove the name. If you never answer all correct, then your name will remain here, and then you will continue to have a chance. Okay, let's go. 2 question. Yeah. Okay, what's your first two answer? 3 and 1. That's correct. That is correct. Okay, anyone needs me to go through 3 and 1? Okay, wait, which one? Which question? Sorry, which one? 2. 2. Okay. So the diagram shows an air pump attached to a deflated tire. So what happens to the mass and volume after 4 pumps are given? Okay, so you pump air inside, right? Okay, now the mass will increase. Why? Because more air went in. More air went in, so mass go up. Volume also go up, volume. So because the tire become like bigger and bigger, right? You can see the volume goes up. The tire become bigger. More air goes in, tire become bigger. You get it? The key here is that it's deflated. What if it's already a fully inflated one? If it's fully inflated, you keep pumping in, right? Will the volume go up? No. Yeah, it might as well, but it will not increase because the air becomes compressed. You get it? Is that all right? Okay. All right. So we remove metal. Cool. Wait first. Oh, let's go to answer 3. Okay, answer 3. Megan. Next 3 answers. Okay, question 3 is 2. Yeah, very good. That's correct. It's 2. 4 is 1. Very good. It's correct again. And wait first. This one 2. Yes, it's correct. Okay, so the 3 answers are 2, 1, and 3. 2, 1. Okay. Explanation now. Anyone needs me to explain anything? Yes. 5. Okay, let's look at 5. Don't worry, even though we are playing a game, right? If you don't understand, please ask me to stop. Okay. We are not rushing for anything. Yeah. Okay, 5. So the classification table shows how some animals are classified. J and K. So which of the following best represents J, K, W, and X? J, K, W, X. Okay, does not go through part in the water, go through part in the water. 2J. Wait, one. K has a 3-stage life cycle. Okay, so you see here are the 2 different stages. Okay, then we know that the butterfly has got a 4-stage life cycle, right? Here, okay. Then which other insect you gotta figure out? Okay, will fit into 4-stage. So this one, the mosquito, go into the 4-stage life cycle. Then look at this. If this is 4-stage, then this has to be like 3. And 3 stages is has a nymph, right? So the cockroach suits this. Oh, happening. The cockroach suits this. Okay. So it's about different options, right? Which one did you choose for this? Actually, which one is it? Oh, I see. You're not too sure. All right, no problem. Okay, done. Moving on. Remove. Now that's a few. Yeah, remove it. Oh. Oh, the bell. Okay, don't worry. Yeah. Right? Yeah, it's getting all the girls. What's happening? Okay, question number 6. Let's Joel. What's that? Wait, first, right? 2 is correct, okay? Good. 6 is 4. 6 is 4. No. Wait. 7 is 4. 4 is correct. Oh, lucky. 8 is 4. Yeah, very good. So far, so good. Wait, 9. Oh no. 9 is 3. Yeah, so far, so good. Okay. 10. 10 is. Yeah, very good. Is that all 5 already? Oh, 5 already. Oh, you all correct. Very good. Okay. Any questions, anyone? 9. 9. Okay. Which of the following diagram shows the correct path? 8. Okay. Question number 8. Wow, it's a long question. Based on the result, which of the following statement is incorrect? Okay, so so usually you see this type of experiment we've done it many times, right? It's about the intensity. The nearer it is, the more intense, and therefore more gas, right? Gases will come out. So the volume of gas, so there's 18, 9, 5, and 11. Water sample. So the water sample also plays a part because if water is cloudy, so less light can go in. Okay, so that's the idea. So the rate of photosynthesis is in Q is higher than S. So you look at Q. Q has 9, S has 11. Now they want incorrect. So this is not correct because S is higher than Q since there are more bubbles. They're asking for incorrect. Which one is not correct? Okay. What can we want? P is clearer than S. P is clearer. Is correct? They want incorrect. Oh, they're looking for the incorrect statement. Okay, so that is the typical one. All right, remove Jobel. Wait, how come cannot remove?
You have to touch on the thing. Can you do it? Because you already skipped it like
Jobel. Yay. Okay, next person. 6. Good. 1 only. Oh, Princeton. But you gotta get it correct, huh? What's the answer? 11. Yeah. What's 11? Okay, what's the answer for 11?
this question is kind of
What's the answer? Princeton. Princeton, you gotta give an answer, no? If not. Princeton. 1, 2, 3, 4. Princeton. Hey, no answer means don't know. Don't know means do again. I give you 5 seconds. 5, 4, 3, 2, 1. What? 1. Wait. 11. No, it's 3. 3. Answer is 3. Okay. So Princeton remains inside. Okay, so Nabil done an experiment. Which one of the following changes? See, usually I jump straight to here, you see? I jump straight here. Which one of the following changes did Nabil make to his setup at point Y of the graph? So you see water come down, then at some point the decrease is faster. This one also fast, then become faster, right? So he switched on the fan. So when he switch on the fan, the volume of water will evaporate faster. Okay, right? So it decreases faster. Oh no, so Princeton remain. Yeah. I go and take. Okay, so you still have some time to quickly finish your last few. Okay, in case you have, we'll do 2. 2 is not that bad. Princeton can remove it. Hey, Princeton. Okay, 12. 1 is correct. Next one. 4. Yeah, very good. Princeton is gone. Then 4 volts. Okay. Any question? 13. 13 on set. Okay, let's see. Okay, which of the following shows the correct amount of water to bend the streets by 3 cm? JKL, amount of water in beaker. Okay. 250, 500. What is this? Wait, where's the water? 3 strip JKL, which are made of different materials. She placed strip J on 2 supports and pour water until strip J bent by 3 cm. She made a trend for 3 kL. She recorded the amount of water required to bend each strip by 3 cm. Okay, so L is the most flexible, K is the least flexible. So most flexible will be able to withstand the most. Got it? So this is the most. Least flexible would only be able to withstand the least amount. So this one, it doesn't matter, right? It's in the middle. That's all. That's all. Okay. Understand? Right. That's all. Next. So Tristan is gone. I want to remove one. Also remove two. Because not enough students to do question. Oh. Alright, people, who's the lucky person? Alright, Kenny. Alright, Kenny, you gotta help us six, right? Come, you can do this, okay? 14. Okay, 1 is correct. So far so good, huh? 15. You wanna try again? Then we'll write down first. Sometimes the answer is wrong. Okay. Next one. 16. 2. Okay, 2 is correct. Alright. 17. 4. Yeah, 4 is correct. Very good. And 18. 2. Very good. So far, correct. Is it the last one already? Is it the last one? 6. Is it 6 already? 1, 2, 3, 4, 5. Oh, one more. One more. 19. 19 is 4. Okay. Huh? Yeah, so all correct, huh? Except for wait, we check first because sometimes the question will be the answer sheet may not be correct. Okay, this one. You want to check again. So suppose you have time, you know, and then you want to you like you got a hunch. Is it called a hunch? Hunch instinct, right? There is something wrong with this, huh? Okay, you want to check again? Everything correct so far, okay? Yeah, everything correct so far. But I tell you the answer sheet didn't put 4 for this. The answer sheet put 3. Okay, but let me check. Okay, let me check what this is. So which of the following represents the volume of water used? The total volume. A, okay, which of the following represents A, the volume of water used in the experiment, B, the total volume of water, and 1 cube of plasticine that Janice would record. Okay, volume of water 450, 425. Huh? So Janice had 150 cm cube of plasticine. She molded all of it into a ball. Everything into one ball. Place it into the container according to the total volume of water and plasticine. Next, she took out the ball and rolled into 2 cubes before placing it back into the container as shown. Right? Why? Wait. At first, how much? Is it 600? 600 with plasticine. 2 of them, right? And then after that, minus 150, right? So minus 150. Volume of water. Yeah, so it's 450. Yeah. No, Kenny. Kenny, you have done well, okay? However, the rule is the rule, okay? You gotta stay in the game. So wait, do you understand this? Understand? All right. Any other question you want to go through? 16. Okay. Okay, Zani. What the rule is like that? What? Then the next time how? Everyone break rule how? Then can give chance. Yeah, I know, but that's the way it is. Okay. In the actual exam, you have to do 28. Right? You gotta get 28. Alright. Next one. Okay, Zalina wanted to find out with the arrangement, press the brightness. Which two circuits should she use to carry out the experiment? So the arrangement of bulbs. That means your bulb must be arranged in series and parallel. Okay. So 2 is A and B. A is parallel, this is parallel. This is series. Correct? You must have parallel and series one. Is that okay? This is parallel and this is series. So you have to arrange it this way. Okay? It can be other option. Okay? But don't worry, Kenny, you did well, right? 6. Getting 6 correct. You got 5 or 6 correct. Okay. So, 19, sorry. So let's go 19. Okay, 19 answer is 4. Which statement explains true rashes observation? Okay, so bigger A, the transport equal amount of water. The other 7 ice cube. So everyone got 7, 7, 7. So there are bubble wraps here. There's obviously a lot of bubble wrap. No, not many and stuff, right? So bigger A has the most bubble wrap. Yeah. So this one has most bubble wrap. What do you put? 4, of course, correct. 2. The more bubble wrap is the more heat. Oh, okay. So this is not about more heat is trapped for it to prevent the ice from melting. This is less heat can enter. You put more bubble wrap, the heat cannot go in, to interact with the water. So the water is colder here. Okay, more bubble wrap, right? The more bubble wrap it is, the more difficult it is for the ice to melt. So this is like a bit of reverse. They say imagine, right? You gotta imagine he did it. It's in our brain. Okay. All right. So next one. Let's see how many we go. Whoa, 6 again. Okay. Oh, it's okay. We never know. Let's go. Annie, don't worry. In the exam you gotta do 28. Okay. So now you only do 6. It's fine, right? You only do 6. Come on, let's go. 20. What's the answer? Sorry? 1. Okay. This time we'll remove your name, right? It doesn't matter. Answer is 3. I got 3. Yeah, I got 3. Answer 3. John cracked each egg dozen how cooked it was. Okay, so here is a lot of water, here not a lot of water, and yeah, so we cook the thing, the solution is more cooked. Okay, least cooked is A, because there's so much water, so the heat is absorbed by the water, right? Not by the egg. B, D, yeah, can you see the level of water? It follows the level of water, right? Yeah, it follows the level of water, okay? Next. You place opposite? No, this one, because there's more water, so it's not so cooked because the water absorbs the heat, right? Next one, again. Sorry? 4, yeah, 4 is correct. Absolutely correct. Okay, what is it for? Let's see. So Jane, Mary, and Katie. Who made the correct statement? So they put this thing measured cylinder, water tank. Wait, there's water here and then there's oil. Water and oil. The temperature increase after some time is again heat. Yeah? So this makes sense. Okay, the water, this is water, right? Okay, the water is inside, okay? The oil is outside. So obviously again heat. How about Mary? The temperature of oil decrease? Yeah, because it's lost heat, right? Heat is transferred, yeah. Because heat always travels from hot to cold. Hot to cold. So all 3 of them are correct. Next one. Kenny, well done. Next one, 22. 3, very good. See, no, we don't. 33. 33. Yeah. 2. 3 is 2. Yeah, very good. It's all correct. Okay, wait, let's finish Kenny's stuff. Okay, 24. 2. It's correct again. 25. 4. 25. No, 25 is 2. 3. Okay, put stop first. 2. Later explain, okay? 26. Last one for Kenny. Come. Yeah, Kenny. Last one. 20. 26. 2. 26. No, it's 3. Okay. Okay, last few, right? We're gonna remove Kenny. Kenny is now out of the game. We only have 2 more. 2 more. What? Don't have 6. Those are last 2 questions. 1 or 2. One. Ashton. Yeah. The game what lucky or lucky is another one. What do you mean? 27. You get wrong, you do again. 27. No answer, also do again. 3. Wrong. 1. This one. so who wasn't chosen? Who's like, oh, giraffe is a lucky one, right? But you don't know, right? Might have a chance later. So no need already, yeah. This one sure. Last question already. Oh, 1 or 2. It's either do or choose. Oops. Do or choose. All right, we get to do the last one. Hey, giraffe, you're the lucky guy for the day. You're the lucky one. Yeah, sounds candy. So you see, no, you got the first 2 easy questions. Okay, 38. Ashton, what's your answer for 38? Four. Ashton, 1. 4. So that y'all can see, right? Okay, so you want me to explain this, right? You write 4. Then why you change to 1? Who influenced you? You got the correct answer. I didn't say anything. Who was the one who said 1? Who said 1 and all? Someone said 1. Then he go and change. You see, right? Guess 1. Okay, let's see this one, right? You got wrong, right? Which of following correctly identify the arrows to the type of forces? So 1, right? A going down, of course, gravitational force, right? Downwards, downwards. Okay, frictional. Friction is always opposite of motion. You see, this guy is pushing this way. Friction is always reverse. So should we be do what? 26, 26, 3. So Anna labeled the ends of 3 metal bar ABC as shown. Okay. So she brought the ends. Well, okay. So there are many options here. Okay. So what do we do? Now, when you have things like that, right? We just look at this one, right? F repel H, right? So what you want to do, you can put like a north here and this one also north. Does it matter whether you put north or south? No, it doesn't matter. Just put north, right? If this north, this north, this must be south, this must be south. So this must be south. This is north. This is south. H is north. Okay, then you can deduce the rest. This is south. This is north. Then because they attract, right? So this must be north, and this must be south. It's north and south. And how about here? South. Wait, what? Cannot be. This one weird. How can so this north? Then this one cannot be north. There is something wrong. Okay, but you gotta check. EF is it magnet? Yeah, because EF repel, right? So this is north. This is south. So this one not north south, no. This one is like metal. It's metal. This is a piece of metal. Okay, this is metal. A piece of metal. Right. So we look at the options, right? Bar B can attract bar C. What's bar B? What's in the GH and JK? So GH. Okay, the one not correct. So GH is a magnet. JK cannot. Yes. That can be done. A and B are magnets. Yes. A and C wrong because JK is not a magnet. Yeah, the one not correct. So that would be the option. Okay. Any other questions to check? 25. All right. Star. Yeah, put a star here. Which one of the following shows the amount of gravitational force acting on the ball at points A, B, and C? So gravitational force is always the same one. Yeah, so what changed? What changed? Where GPE changed. GP. No, I don't need to keep this. You can keep this. You can keep it. Okay, GPE highest here, but gravitational force, it doesn't matter where. Yeah, it's always the same. Okay, do you understand this concept? Do you understand? All right. Okay, so that's all for today. All right, any other questions you want to go through? 29. Okay. What? You sure how to do 29? I give you question 39, right? 39 is no, you want to do 29? No, okay. Yeah, that's all for today. Okay, next week we will be doing the Bukit B. That is all. Bukit B. Okay, you can bring